Hold on. Okay. We'll talk a few about the project. So there will be some unexpected issue. Question? There will be some unexpected situations or issues when you start doing the project. You know, at the beginning, it may seem like another homework problem, where you have the data set. Maybe you clean it a little bit. I don't even remember if you have to clean it, but some pre-processing, and then split, and then do the hypothesis testing, and start training models. You select a few models. The issue I like to kind of talk about a little bit today is really about the neural networks model when you start to use the TensorFlow Keras package. With logistic regression, you really don't have too much of a problem because logistic regression converges quite quickly. If you use the sklearn package to train logistic regression, it'll be even smoother. If you use the from scratch version like we did in homework, then simply follow the homework routine. Same thing. But you'll start to see some unexpected situations when you start using TensorFlow, and partly because you didn't use it in your homework. So it's kind of a new learning curve. But theoretically, on the model side, it would be similar. Model architecture, you have some expectations. Bigger layer, more layers meaning more complexity of the model, and tendency to overfit. That's expected. But the trouble is when you are facing uncertainties, like the process didn't go well. You kind of have different ways to go, but start to I guess can't really decide which way is the right way. Like it might start to experiment too much on one and getting stuck over there. When you start the learning process and plot the learning curve, you may find that the line is plateau. There's no learning whatsoever. It just don't change. What do you do? Right? Of course, you're limited to changing those few things. You can change the network structure. You can change number of layers of the network. You can change the number of hidden nodes. You also can change activation functions. You can change the optimization algorithms. You may even go back to reprocess the data set. But if that process is rigorous, that won't make any changes, right? So this is one typical scenario, and it's a tricky one if you don't have much experience dealing with, applied neural network model training. If you have limited experience, that is kind of daunting process. But try to overcome it. Try to change things around and closely observe the learning curve. Does it change? How does it change? The process is not linear. The model is not linear as well. So the process of improving the training process is also not linear. Don't expect, like, when you tweak one thing, it starts to improve. Don't expect the next time it's going to improve further. It may reverse. So, the process is kind of full of roller coaster style. So don't make too much assumptions. But the learning curve completely plateau is possible. One big reason is too much regularization. So start out without too much regularization. Don't regularize too much to start with. So that's one suggestion. But there can be other reasons that can lead to that. Also, we talked about alternative activation functions. Like we started with sigmoid function, and we say ReLU is almost always better. You know, ReLU especially in the hidden layers, it's almost always better because the training is training would be more efficient and faster. That's true. The speed of training is definitely going to improve. Not necessarily the actual learning in terms of, you know, improving model performance. That doesn't always mean that. So when you switch from sigmoid to ReLU, don't expect the model to necessarily improve. It could reverse. It could degrade as well. So in that case, change it back and observe what happens. Also, the optimization. The default is static learning rate. I think if you change it to Atom or MSProp, it implements some kind of dynamic learning rate. So supposedly it should work better, but not always as well. You know, despite the design improvements. So keep that in mind. Start with reasonable guesses about these hyperparameters, like what's the learning rate going to be. You know, start with reasonable guesses, and change. When you change things to experiment, change one thing at a time. Otherwise, you'll be completely confused about what's happening. Change one thing at a time. If it doesn't improve, fall back to default, and then change other things. So what's causing all of these? Two sources of challenge that's causing all these difficulties. The first one is the correlations in the project data set. It is tricky. It is not as obvious. It's not as clear. It's full of noise. So different from the demo problems and different from the homework problems. The project problem is much harder. I say that because I know that. I made the homework problems easier to the extent that it feels enjoyable to train the models, to get the results, to feel that we're learning. You're learning, yes, but you're not being challenged too much. And our project is full of challenges, unexpectedly. Okay? So that's one reason. The other reason is that the also kind of amplified by the first reason is that the labels, the target outcomes are imbalanced as well. It's quite highly imbalanced. Because of the noisy data, it's harder for the algorithm to figure out where the pattern really is. And given the imbalanced outcomes in the data, it makes more challenging for the analyst, part. You tried many things. You start to see a little bit improvement, and you see that accuracy is 89%. Looks good. Stop trying. That's not good. Look at all sides. pay close attention to what we talked about in the model evaluation, different errors. Try to look at both sides. Do not only look at the accuracy. Accuracy doesn't tell the whole story. In fact, it tells only a little about what's happening. At least analyze the confusion matrix. That's at least. And there you'll discover more areas for improvement, to say it nicely. So that's it.
Other than the confusion matrix, what else? Accuracy confusion matrix and?
Well, I think you know. Once you get there, you know what to think about. Follow the exercises we did in that chapter of the course. You know, try to analyze different kinds of errors, right? And then in this homework, you're going to exercise how to calculate those metrics. So you'll calculate those other metrics, AUC, right? F1 score, right? And you will rarely need to train the model over 200 epochs, different from the homework as well. In a homework, I think it's a very enjoyable process to look at the model training for 100 and 200. You know, look at how smooth the learning curve is. It's just very enjoyable. It's not going to happen in a project. It's not going to happen. But also, you know, don't think that if I run 100 more epochs, it's going to improve. No, it's not going to happen. So, you know, at that point, you can give up and try different things. Don't dream. That's at least, but you know, you can try and you'll find out, of course, right? And this is mostly because of the efficiency of the package. The package is really efficient. That because of the stochastic gradient descent or the mini batch gradient descent, the model is able to pick up what's important in a very few epochs. Anything beyond that is going to overfit the data. So, and you saw that with the more powerful the model is, the better able it is to pick up the trend in only a few epochs. You see that in my research work. In 3 epochs, it's going to hit the optimal, and any point beyond that, it's going to overfit. With these, you know, we say vanilla neural networks, they are less capable, but given the data set and given how much limited trend to learn in the data set, it's going, you know, maybe 10, 20 epochs is going to be, you know, hitting the limit. And then anything beyond that, it's getting worse. But knowing that gives you the advantage. You can leverage the rapid feedback process, and that should be, you should put it to work in your advantage. Quickly change plan. Quickly try different things without learning. In the very early days, like in the beginning of this decade, I would say, when deep learning is new, those computer science they like staring at the computer and for the epochs to go up, like, you know, one epoch and one more, you know, they are waiting, you know, eagerly for the result. In the end, most likely it's bad news, but you know, it's the nail biting moment is kind of very enjoyable. And at the beginning of my learning, same thing happens. Even though it's much faster, I trained for 50 epochs, 67% accuracy. I mean, the accuracy is not even good, let alone to say the confusion matrix. So what I do, I'm just going to train 50 more, and we'll see. And 50 more epochs later, nothing happened. let's try more. and because it makes it very easy to just try more. After you train 50, you're going to continue to train 20 more and 20 more. Computer will not say, damn you, just stop, do something else. It's not going to say that. But, absent any other clue here, I'm just going to try more and hoping things work. Most likely it doesn't. So try different things. All right, any questions? I guess you're now full of questions. Anyway, so the first time around, last year, I taught this course for the first time. I wasn't really expecting. I wasn't expecting these challenges, actually. So almost, to 1/3 or almost half of the teams, they simply take the demo material, run it through, and turn it in. The learning curve is like plateau, like flat. There's no learning at all. From the first epoch, there's no learning. And poor teams try to make up something to justify, or kind of, describe the process. But so I didn't prep them well to have that expectation. And I simply, sort of ran the project as if it's a homework. Because, all the homework made it very smooth. It's very smooth. So I guess they didn't think too much until they work on it on the last minute. This semester, I hope, you guys can do better. I think you can. But I need to better prep you on that. Okay, so I will expect questions after you have started, after Thanksgiving, 3 days before due, 2 days before due, 1 hour before due. I'll be prepared. Anyway, so that's that. Okay, so that's enough about projects.